Hey guys, I hope you're doing well. I originally decided not to release a video this week, but I didn't want to leave you guys with nothing, so I'm putting together this short video. After talking about climate change and what it means for our planet, I thought it'd be nice to circle back to the topic of flat Earth. We're going to look at the lunar phases. This time, however, it seems some flat earthers have actually managed to think of a model of the flat Earth in an attempt to explain the phases. Let's get started.
Okay, so this is a graphic that Cami and I worked on to explain how the moon phases work over the flat Earth. And here you'll see that the sun ellipse is represented as being level to the Earth plane, and the moon ellipse is tilted 5 degrees.
Before I get into it, I want to point out that you guys never seem to be able to produce any model to scale. It's always a demonstration using household objects or a simple illustration like this one, but never actually a model that uses precise measurements. If the flat Earth is true, give us a model that will accurately represent reality, one that can predict the sun and the moon's position, one that shows us the shadow of the eclipses, and one that will give us the exact distance and size of the sun and moon. It shouldn't be hard if the Earth really were flat. On the other hand though, it would be exceptionally easy to debunk your flat Earth models if you were to do that, so I guess maybe it's in your best interest not to.
And one thing about how these phases are represented here, you would have to think of it as, you're like the bottom view. You're standing at the bottom and you're looking up. So if the moon is illuminating like the side of the moon, or the sun is illuminating the side of the moon, from the bottom, you're still seeing half.
Okay, let's briefly look at this model. I can kind of see what you're going at here. The angle of the moon's orbit relative to the sun's causes different shades of the moon to occur. Fair enough. Let's tear this apart. Yes, we would be viewing the moon from below. However, one crucial detail that you missed in your model is that people from around the world will be able to have views from multiple different angles. Someone in America, for example, would have a different viewpoint than someone who lives in, say, Europe. And that changes the game. Your model is only in the assumption that viewing the moon from directly below would produce these types of moons. But let's take a look at a simple example from your own illustration you provided here. Let's take a look at the first quarter. According to your model here, the sun is in the same altitude as the moon during this time. Then the sun illuminates the side of the moon that faces it. When viewed from directly below, the moon appears only to be lit halfway. Now that makes sense for a viewer directly below the moon. However, once you view this from a different angle, it starts to make less sense. Let's say an observer is on the left side here. In his perspective, he would see more than half of the moon light up. In fact, he would be seeing something like a gibbous. On the other hand, if you were on the right side here, you would see more shadow, and the moon would appear more like a crescent for you. This doesn't just apply to the first quarter, it also applies to every single phase here. In addition, the sun and moon must make one rotation per day. Simply the movement of the sun and moon itself would change the angle you view the moon from. And in reality, we don't see multiple phases of the moon per night, and we most certainly don't see different phases depending on which part of the Earth you live in. The sun and moon being so close to the Earth works against you here as well, since angles would be more extreme on different parts of the Earth viewing the moon. I've already listed 2 crucial problems with this model, and we're just getting started.
Basically, what this is showing is that half of the moon, theoretically, is always illuminated. It's just that how it is in relationship to the sun is making it dependent on what phase you see. So, in other words, when it's a new moon, as you can see here, the moon is basically below the sun, so the top of it would be illuminated and we would be seeing the part that is not illuminated.
Excellent proposal! However, we're going to jump back to reality here. So for the new moon, you are proposing that the sun is simply directly overhead. That's great, but due to the tiny proximity of the sun and moon to each other, it is inevitable that the moon would have to overlap the sun here. And even if for some magic it doesn't and can still produce a new moon, different angles of perspective from different locations of the Earth would eventually have someone able to see the moon directly covering parts or all of the sun. In other words, you are essentially saying that a solar eclipse happens once a month. Fantastic. What an extraordinary claim that doesn't match with reality whatsoever.
And during the full moon, it would be the opposite, where the moon is higher in altitude than the sun. So then you would be seeing the full moon illuminated.
Right, so you're now also claiming it's possible to see the sun cover up the moon. Where in reality does that ever happen? Oh yeah, it's in this magical land I like to call nowhere.
And then so on and so forth. As it changes its orientation to the sun, you're just getting a different perspective of that half illumination.
Let's take a look at yet another problem with this illustration. Your model here is an assumption that the sun is very close relative to the moon. In order to produce the new moon, the full moon, the gibbous, and the crescents, the sun would have to be right next to the moon. We'll get to the half moons later. But in reality, we can't always have that. By this logic here, that means the moon will never be seen during the night because it is always with the sun. So in that case, what is it that we see during the night of the sky? Is it not the moon? Of course, I've heard other theories from flat earthers that the moon moves at a different rate than the sun, so it is at times on the other side of the earth where night is. Fair enough. However, during these times that the moon is on the other side of the earth, the sun would only be able to illuminate it to a half moon according to this model, meaning that every time you see the moon during the night, you would only see the first or third quarter phases, because the 5-degree angle of the moon's orbit would not be significant at all to produce any phase other than a half moon. Is it true that the only time we see the moon during the night, only half is illuminated? Of course not. We see the moon in multiple different phases during the night, including the full moon. No matter how you look at this model here, it doesn't make any sense. There will always be more problems than answers. In addition to all of that, saying that the sun can illuminate the moon from across the earth, but not illuminate any parts of the land that has nighttime is just outrageous.
So it's kind of undulating and it's going back and forth at what, 5 degrees plus and minus? Would that be accurate?
That's, yeah, what we're using for the 5 degrees is we're using actual observations of what they're seeing on the ground, and they are seeing a 5-degree slant.
I would love to see these calculations. Funny how you would try to get this part exactly to scale, but couldn't bother to make anything else to scale.
One thing I do want you to explain, Cami, is if it was the moon causing the eclipses, he said that we would have an eclipse every 29 and a half days. Tell us why that is not true.
Well, it is the moon causing the eclipses, at least for the solar eclipses. It's just that the moon doesn't always overlap between the sun and the earth perfectly to block out the sun's rays. But yes, I did bring up this point earlier myself, so I would love to hear an explanation.
Now, why that is going on, the sun's path is going over, think of it as a circular path over the tropics and the equator, and how it's maintaining that circular path. The moon, why the sun is doing a circular path, is doing more of an egg-shaped path. If they line up on top of each other or within how many degrees, you'll get the eclipse, but it has to be, it's a side-to-side arrangement. It's spirographing side to side, and as soon as it goes far enough out the side, you're not seeing it at all. It's under the rays of the sun.
Wow, I had to cut out so much because she just couldn't find the words to properly express herself. Now, I think I got the gist of it. She said, and correct me if I'm wrong, that because the moon's orbit is slightly elliptical, it doesn't always appear directly below or above the sun during the ascending and descending nodes of the diagram. Therefore, you won't always have an overlap. Alright, so this is almost the same idea as what happens in reality in the heliocentric model, but there's one big distinct difference. In the flat earth, the sun and moon are very close to the earth. I would use exact measurements here if I were provided any, but since I haven't heard any exact distances and sizes, we'll just go by the claim that the sun and moon are close by. Now, because of this, like I mentioned earlier, different locations view the sun and moon from different angles. Because of the proximity of the sun and moon, location differences will result in perspectives that will change the shadow of the moon, and that includes the full and new moons, and allows some locations to experience eclipses every single time a new moon should be present. In the actual heliocentric model, this isn't a problem, since slight changes on the Earth's location isn't going to alter much in terms of angle, due to the sheer distance of the moon. Solar eclipses will only happen once the moon's path happens to pass between the sun and Earth. That is the key difference between these two models.
Okay, that makes sense. So basically what it comes down to, and we talked about this in the beginning, and we all do it, this is kind of why I did the show, why do we play by their rules? Because we are constantly confronted with the physics and the math that are sort of proving, I guess, the heliocentric model.
Such vagueness. If you want to go ahead and make a separate video debunking all the, quote, physics and math of the heliocentric model, unquote, then feel free to do so. For now, I'm just going to point out something else that is quite important. From this model you have here, a correction I would make is that the moon's orbit shouldn't just be 5 degrees tilted. Allow me to explain. As you know from the heliocentric model, the Earth rotates once per day. Translated on the flat Earth model, that means the sun and moon would have to make 1 revolution per day above the flat plane. That means according to your model here, the moon would have to circle around and undergo the ascending and descending nodes all in one day. In other words, by saying the moon simply has a tilt in its orbit is the same as saying the moon goes through all its lunar phases in one day, which is outrageous. Here's a small correction that would make your model slightly better, even though it would still have many problems, and that is to make it so that the moon slightly ascends and descends every month as it orbits, instead of tilting the orbit itself. Does that make sense? This is so dumb how I could make a better model for the flat Earth than you guys can. Of course, there would still be many problems to explain away, such as my point earlier about the moon at night having more phases than just a half moon in reality. I'm sure you'll get to that once you develop your flat earth model a bit more, although I doubt you'll be able to solve all the problems I proposed here. Anyway, I know this is just a hypothetical model you guys came up with and is not a consensus among flat earthers, since a lot of you guys claim the moon produces its own cooling light and whatnot. Such madness. This is fun though. Keep coming up with new models so I can tear them apart. Thanks.